Electrical property of matter that creates electric and magnetic forces and their interaction. An example is dragging your feet across the carpet. Like charges repel and opposite charges attract. One way to observe charge is to rub a balloon back and forth across your hair. The object's electric charge depends on the imbalance of its protons and electrons. Objects are made of an enormous number of neutrons, protons, and electrons. Whenever there is an imbalance in the number of protons and electrons in an atom, molecule, or other object, it has a net electric charge. Electrical conductor, a material in which charges can move freely and that can carry an electrical current. An example is a metal cord. Electrical insulator, a material that does not transfer current easily. An example is cardboard, glass, silk, and plastic are all insulators. Can be changed by the transfer of electrons. Protons and neutrons are relatively fixed in the nucleus of the atom, but the outermost electron can be easily transferred from one atom to another. Charges move within uncharged objects. The charges in a neutral conductor can be redistributed without contacting a charged object. Electric force, the force of attraction or repulsion between objects due to charge. The attraction of tissue paper to a negatively charged comb and the repulsion of two balloons are examples. Electric force depends on charge and distance. The electric force between two charged objects varies depending on the amount of charge of each object and the distance between them. The electric force between two objects is proportional to the product of charges on the objects. If the charge on the object is doubled, the electric force between the object will also be doubled. Field, a region in space around a charged object that causes a stationary charged object to experience an electrical force.
A ball rolling downhill moves from a position of higher gravitational potential energy to one of lower gravitational potential energy. An electric charge also has potential energy, electrical potential energy, that depends on its position in an electrical field. Usually, it is more practical to consider the potential difference than electrical potential energy. Potential difference is the change in the electrical potential energy of a charged particle divided by its charge. This change occurs as a charge moves from one place to another in an electric field. Most common batteries are an electric cell, or a combination of connected electric cells, that convert chemical energy into electrical energy. One terminal is positive and the other is negative. A summary of various types of electric cells is given in Table 1. Why did I say that? Current is the rate at which charges move through a conductor. The SI unit for current is the ampere. 1 ampere or amp equals 1 C of charge moving past a point in 1 second. Resistance is caused by internal friction, which slows the movement of charges through a conducting material. Because it is difficult to measure the internal friction directly, resistance is defined by a relationship between the voltage across a conductor and the current through it.
Circuits are wires that connect at the terminals of the battery or the light bulb. Charges that build up on one of the terminals of the battery have a path to follow to reach the opposite charges of the other terminal. Together, the bulb, the battery, and the wires forms an electric circuit. Because of the voltage of the batteries, electrons move through the wires and the bulb and a negative terminal and the positive terminal. Then the battery adds energy to the charges as they move within the battery from the positive terminal back to the negative one. A schematic diagram shows the construction of an electrical circuit or apparatus. Many of the devices you use on a daily basis, such as a cell phone, require electrical energy to run. The energy from these devices may come from a battery or a power plant miles away. The cell phone has a battery inside of it to help hold its charge. But to keep that battery going, you have to plug it into a wall. You have to plug it into a wall, which comes from a power plant that's probably miles away.
Way over there.
To prevent overloading circuits, fuses are connected in series along the supply path. A fuse is a ribbon of wire with a low melting point. If the current in the line becomes too large, the fuse melts and the circuit is opened.
This is a mini fuse.
Many homes are equipped with circuit breakers instead of fuses. A circuit breaker is magnetic or a bimetallic strip. A strip with two different metals welded together that responds to a current overload by opening the circuit.
Okay, so what we're going to do is we're going to demonstrate a simple series circuit using some small wire, a light bulb I stole out of a flashlight, and a C battery, 1.5 volt. First, you take this knife, strip some end of this wire off. Like that. The same on the other side. Like that. So now we have uninsulated wire. So now we're going to take the battery and a piece of electrical tape. We got our negative side here. We're going to put the wire on the negative end. Tape that down with the electrical tape. So now we got that. Just like this. Now we're going to take that little light bulb. I'm going to put it on
The positive side.
This is the negative side of the light bulb, so we're going to make the current like this. And there we got our light. So this is our series circuit. And right now, this circuit, the electrons are traveling this way. I don't know if that is clockwise for you guys, because they come from positive and they go back to negative. So if we flip this, so if we had the wire up here and we connected down here, then it would be going the other way. But anyways, that's our series circuit.